everyone. In this lesson, we will be starting our journey into motion by talking a little bit about distance and displacement and introducing these terms of scalars and vectors that are going to be coming up throughout our year together. So let's go ahead and get started. All right. Now, why this is important is kind of summed up for us by this wise Lewis Carroll quote, right? That ultimately, when we're talking about motion, we need to be able to have a plan. We need to be able to describe where we've gone and how far we've gone and where we were to start and where we are at the end. We need to be able to really precisely quantify our motion to describe how something has moved, how it's changed over time. And so our goal today is really to give you some of the terminology to start to be able to quantify how something has moved. Okay, so a few terms just to get us started. There are like three big terms for today. The first one is position, which is not even a really fancy physics term. That's something you've probably used in everyday life just to describe the location of a particular object. Now, anytime I'm introducing terms, I'm going to provide you a definition in this format. So just to unpack that for you, I'll always provide you the term first, and then in parentheses, you'll get the variable that represents that term in an equation. So if you see an equation that has x, you know that x represents the position of the object, all right? And then, of course, I provide you with that definition to let you know what that thing is. All right, so position describes the location of an object. We generally measure that from some sort of reference point of your choosing. Sometimes it could be like ground level represents position 0, and then we measure in meters how far above ground level an object is, or it could be, you know, feet from the door or anything like that. We just want to be consistent about what our 0 point is, and then we can just measure our location or our position from that 0 point, that reference point. All right. So position, our first big physics term, and we're going to dive right into our second, which is displacement. Displacement then is represented by the variable d. That's very logical, good. And that represents the change in an object's position. So if I were to write that out mathematically, we got our first equation coming up. D is equal to, we've got a little triangle right there. Now, some of you may recognize that that is no ordinary triangle. That is, in fact, the Greek letter capital delta, and delta means change in. So literally it says displacement equals change in position. Or if we want to further break that down and further unpack what exactly that means, we can write it this way. All right. Now, there are going to be times throughout this year when we're going to use little subscripts to sort of further clarify some information about our variables, because sometimes our variables are changing or we're describing multiple objects, and so we need to be able to keep track of which measurement we are looking at. And so this is one example of that. So we've got d equals x with a subscript f minus x with a subscript I. Now, in this case, the subscripts f and I describe times, essentially, when the object had that position. And in this case, the f means the final. So xf is the final position, minus xi represents the initial position. So basically you're saying, where did you end up? And then subtract, where did you start? And then that tells me how far you went, okay? Or the difference between those two locations, right? So that's our definition for displacement, okay? Overall change in position. But we don't usually use the term displacement all that often in sort of our everyday life, right? Usually we use the term distance, and displacement and distance are similar to each other, but they are different in some key ways that I really want to unpack for you. So you may see on your notes a little diagram that kind of points out for you the distinction between displacement and distance. So go ahead and take a guess for now what you think may be, like, how you might describe the difference between distance and displacement. All right, so to illustrate some of those differences, let's just dive into a few examples and see if we can really, unpack what's going on here, okay? So let's say that I'm, feeling very ambitious and actually get out of my seat and walk around, right? So if I go and walk 8 meters east, and then I stop and like say hi to my kid, and then go another 6 meters east, first question is, what distance have I traveled? Well, to calculate my distance, I'm just figuring out in total how much did I walk? How many meters did I go? All right, so I can just add up 8 meters plus 6 meters, gives me a total of 14 meters as my distance that I traveled. Cool, we're off to a good start. The next question then is, what is my displacement? Or in other words, how far am I now from where I was when I started? All right, and so what can be helpful is to just draw a little picture from your starting point to your ending point, a little arrow going that way. And so I see that since all of my journey was all in the same direction, my displacement is the same as my distance. I am 14 meters east of where I started. Easy peasy. All right, let's do another example. Woo! All right, so say this time I walk 8 meters to the west, and then I get distracted, I realize I forgot something, and so then I walk back 6 meters to the east. Right? Now, what distance have I traveled? My distance, still 14 meters. That's still the total length that I have traversed here. But my displacement now is a little bit different. So again, I'm going to draw an arrow representing the displacement that goes from my starting point to my ending point. And that looks something like this. It's much smaller than it was previously because I kind of doubled back on myself. And so then if I want to figure out how far that is, in this case, all I have to do is subtract, because those two journeys, the 8 meters and the 6 meters, were in opposite directions. So 8 meters minus 6 meters gives me 2 meters, and overall 2 meters to the west. So I could write out 2 meters west, or depending on how I've defined my directions, if I've said that east is the positive direction, which is what I kind of assumed in the previous question, then I could also just say that this displacement is negative 2 meters because it's going in the negative direction. If east is positive, then west would be negative. All right, good. Let's mix it up a little bit more. I'm still walking 8 meters to the east, and then I pivot. I make a quick turn there and go 6 meters to the south. What distance have I traveled? Yeah, it's still just 14 meters. I mean, it's not changing. I'm still walking a total of 14 meters. But my displacement, that's a little bit trickier here. So again, I'm going to go ahead and draw in an arrow from my starting point to my ending point, and it looks something like that. Now, when I draw out my 8 meter journey and then my 6 meter journey and then my overall change in position from start to finish, that should look kind of familiar to you. That's maybe a shape that you have seen before. Any ideas for how we could calculate that displacement, that length of that blue arrow right there? If you said Pythagorean theorem, I agree. This looks like a beautiful right triangle, which means I can bust out a little a squared plus b squared equals c squared action on this. All right. So in this case, my displacement is the hypotenuse, and really the displacement is almost always going to be the hypotenuse for our purposes here. And so that means that the displacement squared is going to be equal to 8 squared plus 6 squared. A squared plus b squared. All right? That gives me d squared being equal to 100, or in other words, the displacement is the square root of that. It is 10 meters overall to the southeast. That's the general direction that we went in. All right, one last one. Let's say I am so excited about talking about distance and displacement, I decide to start doing some cartwheels. All right, so I can't even do one cartwheel, let alone go around the entire earth and like over oceans, but whatever, we're gonna go with it. All right, so let's say that I get super excited and I cartwheel all the way around the circumference of the earth, which is about 40,000 kilometers if you haven't memorized that already. And then then I end back up in Santa Ana, where I began, just in time for our next class together. Hooray! What distance have I traveled? I went that full 40,000 kilometers and I'm exhausted, all right? So like that all counts towards my distance, but what is my displacement? Big old goose egg. Yeah. As far as you can tell, like if I start here and then you don't see me while I'm cartwheeling around, and then you just check back in at class, as far as you're concerned, I haven't moved at all. Like I'm in the same place that I started. So my displacement is 0. Bummer. All right, so no cartwheeling around the earth for me. So to summarize the distinction, too many D words, the distinction between distance and displacement. So distance, we consider the entire path that you traveled, all those steps along the way, whereas displacement, it's just starting point versus ending point. How far apart are those? That's it. So we don't care about all the journey in between, just the start and the end, all right? Distance, we don't worry about direction, but for displacement, we do care about direction because we care about where we ended up. Distance, you've kind of been all over the place and we don't worry about that. We just add everything up regardless of direction. But displacement, we really got to keep track of the direction that each part of the journey was in. Distance is always going to be positive. No one ever says that, you know, I drove -5 miles to school, like, no one says that. It's just always positive, all right? Whereas displacement can potentially be negative depending on how you define your directions. Now, oftentimes we will say like forward is the positive direction, so then backward would be the negative direction, or up might be your positive direction, so then down would be negative, north is positive, south is negative, etc., etc. All right, so displacement can be negative because we care about that direction, and negative can communicate direction for us. All right. And that distinction brings us then to 2 larger categories that we're going to be dealing with this year. All of our measurements, all the terms and all the numbers that we deal with this year are going to fall into one of 2 categories. They're either going to be scalars or vectors, all right? Now, scalars, quite simply, just have a magnitude. Okay, or in other words, a size. It's some measurement where we sort of know how big that measurement is, but that's it. Whereas the vector quantities, we include both that magnitude or size and direction. Direction matters for vectors. It doesn't really matter for scalars, all right? So what that means then in terms of like recording these values is that scalars will have a number to quantify like the magnitude and a unit to tell us kind of what to make of that number. So scalars include numbers and units. Vectors include both those things as well, plus direction again, all right? And so then our examples of each of these, so distance would be an example of a scalar quantity where direction doesn't matter, so we just have a number and a unit, boom, we got our distance, whereas vectors would include things like displacement, where we really want to include a direction on that measurement. All right, cool. Couple tips for you to calculate displacement. When in doubt, draw a picture. Pictures are such, like, they're your best friend this year, so draw lots of pictures. Do little arrows. It's great, all right? Now, if all of your movements are along a single dimension, so they're like just north and south, or they're just up and down, or they're east and west, or whatever, those are pretty simple. What you do is you just add everything in one direction, whichever way you decide to be your positive direction, and then you subtract everything going the opposite way in the negative direction, and boom, you have your overall displacement at that point, all right? Now, if it gets a little bit more complex and you've got 2 dimensions, so you've got like north and east, or you've got up and to the side or something like that, then what you'll need to do is break it into parts. You'll need to find the displacement for each of those dimensions, so your north-south displacement and then your east-west displacement separately, and then Pythagorean theorem that thing up. Good. All right, cool. Final check for understanding. Let's say you are craving some boba because it is hot. And so you get on your bicycle, you ride 0.5 miles west, all right, and go around something. And then 4.4 miles to the north. Awesome. And then you go 3.5 miles east. And then finally, to actually get to 7 Leaves, you finish up with 0.4 miles south. What distance did you ride? Well, to find the distance, all we have to do is just add all of those up. So 0.5 miles plus 4.4 miles plus 3.5 miles plus 0.4 miles should give you a total of 8.8 miles that you covered on your bicycle. Good for you. All right, then what is your displacement? All right, now with displacement, we have to keep track of direction. We can't just add up all of our numbers. So I'm going to break it down, since this is in 2 different dimensions, into the north-south and into the east-west, All right, so for the east-west dimension, I know I'm going 3.5 miles to the east and then back 0.5 miles to the west, okay? And I know it didn't happen in that order, but I can kind of add these in any order that I want to, as long as I'm sticking within a single dimension, and that's okay. I'm allowed to do that. All right, so 3.5 miles to the east minus the 0.5 miles west that I covered previously gives me an overall east-west displacement of 3 miles to the east. And then in the north-south direction, I went 4.4 miles to the north, backtracked 0.4 miles down south, which gives me an overall north-south displacement of 4 miles to the north. And then I can take those two displacements, since they are perpendicular to each other, and just Pythagorean theorem it up. So d squared equals 3 squared plus 4 squared. So when I add those together and then square root it, I will get an overall displacement of 5 miles to the northeast. All right, you are now an expert on distance, displacement, vectors, scalars. Go forth and be brilliant.